Okay, so on this example, it says an inner city revitalization zone is a rectangle that is twice as long as it is wide. The width of the region is growing at a rate of 27 meters per year at a time when the region is 220 meters wide. How fast is the area changing at that point in time? So let's draw ourselves a little rectangle and try to get what they're saying. Okay, so there's my rectangle. They're saying the width, so this is the width, and this is the length, you know? And they're saying the width right here says is twice, oh, wait. That it's twice as long as it's wide. Whoops. Let me try that again. Got that backwards. Okay, I better read the fine print a little bit better. Okay, let me try that again. So it's twice as long as it is wide. More like that, huh? So, all right, so here's the width. Here's the width. The length is 2W, isn't it? The length is twice the width, right? Twice as long. Okay, as wide. Okay, so what's the and they're talking about the area. How fast is the area changing? So they want dAdt. That's what they're asking us for. Do you see that? How fast is the area changing? What's dAdt? Change in area over time. So we got to come up with the area formula. What's the area of a rectangle? Well, it's length times width. You remember that? Right? You just multiply. Like if this is like if you have a rectangle that's what? Let me just say rectangle that's 1, 2, 3, 4, 5 squares down and 1, 2, 3 across. You know there's 15 in here, right? Because it's 3 rows of 5. You just multiply one side by the other. So now the trick is I've got to plug in for that L 2W. So it's 2W times it, because length is 2W. So that's then 2W squared. Area is 2W squared. So now, so step one, um, yeah, let me give some steps here. Um, they're asking me, yeah, let me be a little more formal now. They're saying the width is growing at 27 meters per year. So that means dW dt is positive 27. 27 because it's growing. If something's getting bigger, its growth, its change is positive. It's shrinking, it'd be negative. Normally we think of negative as left or down, but when it comes to growing or shrinking, growing is positive, shrinking is negative. All right, so it's growing. The width is growing. So notice this. So the first step. So let me give some steps here. Step one, identify rate variables, and that's dAdt and dWdt. Why? Because they mentioned both of them. How fast is the area changing? dAdt. And the width of the region is growing. 27 meters per year. That's changing. Rate of change of the width. Okay, so that's step one. So step two, get an equation with only A and W. Why? Because those are my two variables, A and W. So at first I had L times W, and I plugged in for L, 2W. So now I have an equation that just has A and W, with only A and W as letters, I should say. You can have other numbers and pi and stuff, but no other letters, with only A and W as letters. So now that's step two. And then step three, so step three, down here, ddt implicitly both sides. So then you take that equation, which is A equals 2W squared, and we're going to ddt the left side and ddt the right side, both sides. And so then that becomes dA dt equals, the 2 just sits out front. Now, what do you do with the W? Well, the other two comes down. W to the first power times dW dt. Did that implicitly, right? All right, so now we can plug stuff in. So step 4, plug in your numbers. So plug in your numbers. So dA dt is what we're looking for. So we're going to say, all right, dA dt equals 2 times 2 times W. What's W? Do we know W? 220 meters wide. Yeah, that's the width. And dW dt, oh, right here, 27. All right. So if you hit the buttons on your calculator, I'm going to use my little, you can go, what's that, 4, 220, and 27, 4, 220, and 27, 4, 220, and 27, 4, come on. Here we go. What do you get? 23, 760? 23, 760, 23, 760, 23, 760. Beautiful. There's the answer. And oh, and what are the units? It's square meters per year. Square meters per. How do I know it's that? Well, it's area. Are you familiar with area is always in square meters? Because area's got squares. Like if I look at the area here of this little make-believe rectangle, and I've got, the total area would be like the total number of squares. I'm not drawing the best here. Total number of squares in here. So the area is how many actual squares, square meters, meters by meters. Right? We knew it was meters, was the length and meters. So the area is square meters and it's per year. How do we know? Well, it said per year as time, and this is area per time. So square meters per year. And so there we go.